Hello friends, welcome to GSR ChemTube channel. Here we are going to discuss about atomic structure chapter. In that the principles which help us to understand the electron configurations. Let us see now. The filling of electrons into different orbitals is governed by the following rules. They are Abo Principle, HUND'S rule and PAULI'S Exclusion Principle. Let us see one by one this. First, Abo Principle. Abo is a German word which means building up. Thus, this rule is also known as building up rule or building up principle. The building up of orbitals means the filling up of orbitals with electrons. So, this principle states that the electrons in an atom occupy the orbitals in the order of their increasing energy. In other words, electrons first occupy the lowest energy orbitals available to them and then enter into higher energy orbitals only when the lower energy orbitals are completely filled. Since the energy of an orbital in the absence of any magnetic field depends upon the principal quantum number value n and the azimuthal quantum number value L, so the order of filling of orbitals with electrons may be obtained from the following generalization also. That is, the orbitals for which the n plus L value is lowest are filled first. When more than one orbitals have the same value for n plus L, then the orbitals with the lower n value are filled with electrons first. The sequence in which the electrons occupy various orbitals can be easily remembered with the help of Molar Diagram. So this is a Molar Diagram which helps us in understanding the filling of orbitals with the electrons in increasing order of their energy can be easily done. So from this you can say first 1s orbital is filled with electrons. After completely filling this, electrons occupy 2s. After this 2p, 3s, 3p, 4s, 3d and so on. In this way, electrons occupy the lowest energy orbitals first and then they enter into higher energy orbitals. Here you can see the order of filling of various orbitals with electrons obtained by this rule can be shown like this. This is the increasing order of the energy of the orbitals. Next, HUND'S rule. This rule deals with the filling of electrons into degenerate orbitals of the same subshell. Here the word degenerate represents same energy. The orbitals present in a subshell will be having same energy. These orbitals the same energy are called degenerate orbitals. Anyhow, a subshell contains only one orbital, whereas p, d and f orbital subshells are having more than one orbitals. So those subshells are having degenerate orbitals. Hence, this principle is very important in guiding the filling of electrons in p, d and f orbitals. HUND'S rule states that electron pairing takes place only after all the available degenerate orbitals are occupied by one electron each. For example, consider carbon atom whose atomic number is 6. It has 6 electrons. The first electron goes into 1s orbital of K shell or first shell. In this way, first electron enters into S subshell of or S orbital of first shell. The second electron will be paired up with the first electron in the same 1s orbital. In this way, second electron also comes into same first s orbital and pair up with the first electron existing already. Similarly, the third and fourth electrons occupy 2s orbital of second shell, that is L shell. So, third and fourth electrons occupying 2s orbital here. The fifth electron goes into one of the three 2p orbitals of second shell, let it be 2px. Here we can see second orbital has, second shell has 2p subshell, it has 3 orbitals which we can say 2px, 2py, 2pz. Now these 3 are called degenerate orbitals. Now the fifth electron enters into one of these, let us consider that as a 2px. Since the 3p orbitals are degenerate, the sixth electron goes into either 2py or 2pz but not into 2px. Thus, the electron configuration of carbon can be written as this: 1s2, 2s2, 2px1, 2py1. This also can be represented diagrammatically as this. Here the fifth electron entered into 2px orbital, and these 2px, 2pa, 2pz are degenerate orbitals. That is why the sixth electron, instead of pairing up with 2px, it entered into one of the two vacant orbitals, here 2py. In this notation, these arrow marks represents the electrons, and the electron or arrow mark which is shown in the upward direction represents the electron revolving in the clockwise spin, and its spin value will be plus half, whereas the arrow mark showing downwards represents the electron with the anti-clockwise spin, and its spin value will be minus half. HUND'S rule is also known as the HUND'S rule of maximum multiplicity. This HUND'S rule of maximum multiplicity states that for a given electronic configuration, the term with maximum multiplicity falls with the lowest energy. According to this rule, electron pairing in p, d and f orbitals cannot occur until each orbital of a given subshell contains one electron in each, or singly occupied. Pauli's exclusion principle. In 1925, Wolfgang Pauli proposed this exclusion principle. This principle is very useful in construction of electron configuration of atoms. According to this Pauli's principle, no two electrons in an atom can have the same values for all the four quantum numbers. That is, for example, in 1s orbital of helium atom, there are two electrons. According to the concept of quantum numbers and Pauli's principle, their quantum numbers can be given like this. So here you can see 1s orbital of helium has two electrons, and the quantum numbers for these two electrons are written like this. The plus symbol before half represents the clockwise spin of first electron, and this negative symbol represents the anti-clockwise spin of electron respectively. Thus the two electrons having same value of n, l and m could have different values of s, that is, their spins are opposite in direction. This leads to a very significant observation that an orbital can have maximum two electrons, and these two must be having opposite spins. For example, two electrons in an orbital can be represented by either these two ways or these two ways. In 1 and 2 representations, the two electrons have opposite spins. That is, one is having clockwise spin, that with the positive halves value, and the other one is in the anti-clockwise spin. In 3rd and 4th representations, the two electrons are having the same kind of spin, either clockwise or anti-clockwise. In the light of this Pauli's exclusion principle, the representations of 1 and 2 are correct, whereas 3rd and 4th are incorrect, because these two electrons in these two representations will get the same set of quantum numbers for both, which is controversial with Pauli's principle. So these two are correct, these two are incorrect. Thank you for watching our video. Please subscribe our channel, press the bell icon and for latest updates.